Hello, everybody, and welcome to yet another episode of Analytics Mindset. In this episode, we will go through derived columns with select. We have gone through the select clause, the from clause, the where clause, etc. This time, we are going to go into something a little bit more complex. First of all, if you haven't seen it before, I have a series on database videos that you should be at least somewhat familiar with SQL syntax in order to get the most from this video. If you have not seen it, please, I will leave somewhere over here below. Just click on that list and get yourself familiarized with at least some of the basics from SQL. Alternatively, if you already have SQL experience, we can just jump straight into this. First of all, we will be looking at the houses table that I have already mentioned in quite a bit of other tutorials. I will not go that much into the data because it's pretty self-explanatory. It's just made up data. Don't worry about the meaning of the numbers that much. I just made it up myself. We are going to start by creating the table. We're creating the houses table with all the other columns we had before, with the exception of down payment and years since renovation. These are two new columns that we will be using for a lot of stuff later on. You can see here, I just created a table and I'm going to insert these values all the way here. I'm going to insert all of these. And 12, now I have 12 rows in this table here. You can see here all the columns, I already explained them a lot of times before. The only two new ones are down payment, that is the amount of money put when the house was bought. If you ever bought a house, you're familiar with this. And years since renovation. This is going to be how many years it has been since the house was renovated. And if not, it's going to be null. We are going to look first at the table itself with doing a select star. This is how the table looks like right now. This is all the data that we have. As you can see, I get all the different columns here: owner ID, street, state, price, price date, years since construction, down payment, and years since renovation. I'm going to assume, and this is mostly the biggest use for these derived columns that I'm going to explain here, that I need a new column. I have a down payment, but I want to know how much that is as a percentage of the total price. Why do I want this? If you're a homeowner, you want to know how much down payment you're putting into. If you're the bank, the more down payment your customers put, the less risky a loan is. There is a ton of considerations why you may want to know this instead of just the raw number of I put $40,000 in a down payment. That might be very different putting $4,000 in a $200,000 home versus a $1 million home. It's going to be awfully different between the two of them. For this, we are going to try to get a percentage by dividing down payment over price. How do we perform this in SQL? It is pretty straightforward, actually. Math in SQL can be very straightforward compared to other operations. We are just going to select all, so all the values that we had before, and then we're going to take down payment and divide that over the price. You can see here the syntax. I take everything from houses, and then I'm going to take the down payment column and divide that column by the price column. And if I do this, you can see here, I have nothing. And we know that it's not correct. And there's no column name either. Why this happening? Well, if we look back to the inner data, see how down payment is an integer and price is an integer. Price shouldn't actually be an integer because it can have decimals, but we're going to ignore that for now. Let's just assume that we got that from the bank for whatever reason. Now, when you try to divide those two, you get decimals in between. And because the new column is assuming as an integer, I will get 0 because that's what SQL treats something that cannot be put into this column. The technical explanation behind data types and why that's not happening goes well beyond the scope of this video. Just know that you should know your data types. And if you're creating a new column, you need to have a specific data type that can hold that. In this case, we need some data type that can hold decimals. Luckily, this is very easy here. There is a ton of ways you could do this. You could change so many things to make it possible to get the decimals in the new column. For this specific case, we are going to do something very simple. We're going to call the cast function that allows us to convert something into another data type. And we're going to convert both of these into floats. If I do this, now I get the actual division between these two numbers here. Now, I don't like this though. This is horrible. It looks bad. It doesn't have any column name. If I were to export this to Excel, I will get these random numbers here, and whoever doesn't take the time to actually do the math between the price and down payment would be awfully confused. We can solve that in SQL too. We can take it to the next level. First, I want it to be a percentage. So it needs to be between 0 and 100. This is not between 0 and 100, as you can see. It's between 0 and 1. I need to multiply it, scale it, if you want to 100. We're going to use also the round function because I just want a percentage with 2 numbers and 2 decimals. And we're going to use the as function to allow us to give an alias to these column names. As you can see here, this is the more formal version of this query. I'm going to take the select all from all the columns. Then I'm going to call round. What round is going to do is constrain all this division in 4 decimal places. First, I'm taking the 4 decimal places, and then I'm multiplying by 100. We could do it the other way around. We could just take the division first, then multiply that by 100, and then chop off the 4 last digits. But it's up to preference. In some more complex problems, it might be an issue or a concern. Here it is not. As you can see here, we get our down payment percentage. Some of them are very high, like this one here. This is 16% of the price that we paid. Here, others are very small, like 3%, less than 0.5% in the case of this 3 here, etc. Now, this is something presentable. You can present this to other people and they will understand it in an Excel document, or just print it out if you are that kind of old-fashioned. Now, we have that column that gives us the percentage. Can we just filter by it? I mean, we already have that function. We already have the define. We could just, I don't know, put in the word clause and see what happens. Unfortunately, SQL is not that smart in that regard. We cannot filter by this because this is an alias. This is not an actual column. This column here that we're looking when we do this only exists only in the view. It only exists because we're creating the operation here and we are not doing it inside. That is the reason why we cannot do this straightforward. However, it is not impossible. This is going to be a little bit more complex. If you want to go back and take some time to refresh your SQL basics, you can, but there is a lot of ways we can do this. One of them is, let's just call the whole definition. We have here the formula. We can do the same thing here in the word clause. And we're going to do that. What we're saying here in plain English is whenever the down payment over the price as floats rounded to 100 and multiplied by 100 is less or equal to 1, included. And as you can see, all of these are more or equal to 1. All of these are more or equal to 1, as you can see here. This is a very good alternative, and it actually shows you what the query is doing. However, it is very cumbersome. And if you have long formulas with a lot of definitions and a lot of different operations, you may not find this as practical as usual. There are alternatives. The first one is we can use a subquery, or we can also use a common table expression. These two allow us to create a derived table with the column that we just created and then query by it. As you can see here, this is a subquery syntax. We are using a select all from this table, and this table has the column that we had here. And we are saying then where down payment percentage is equal to 1. We can run this first. Then the query inside is going to give us our new column here. And then we can take this and query by this specific column. Why can we do this? Because we are creating another table here, and then we're feeding that table into a new query. The new query is looking at this houses percentage table that already has this column. That is a very important consideration because it allows you to save yourself this definition in the word clause. And again, this is a very simple example, but if you were doing operations with way more complex formulas, then this syntax might be better for you. A more popular approach, if you wish, is a CTE, also known as a common table expression that most of you should be familiar with. CTEs allow you to do a different syntax. It is the same concept as a subquery. We are saying with the house's percentage table, and then we're declaring it by everything inside this query. Select everything from that table where down payment is more or equal to 1. There you go. It is exactly the same result. Now, it is up to personal preference. There are some considerations in performance and speed. However, we are just querying less than 12 records. There is not really a big consideration here. If you were querying millions of records or thousands of records, that would be a very different consideration. But for most cases, subqueries and common table expressions are pretty equivalent within each other. Now, let's say that we want to create a new column, and this is going to be the difference between years since construction and years since renovation. We already created our down payment percentage column. Now we can do the same with this new column. We're going to call it years between construction and renovation, and it's going to be defined as taking the years since construction and subtracting the years since renovation. I will take this. And as you can see, whenever it's null, I'm going to have null here. Why? Because if you add up, subtract everything to null, it's going to be null. There are some other ways to handle nulls. However, for the purpose of this video, just know that if you do any operations with a null, you're going to get a null. That's something important. In this case, we don't worry because that means there is not really a difference between construction and renovation. Simply speaking, the house was never renovated, therefore we just don't have a value for that. Now we want to use the where clause to filter this new column when it's not null. So actually here is not null, and where the down payment percentage is more or equal to 1. We can do that. As you can see here, we are going to do select star, then take our first derived column as down payment percentage. Then our second derived column as years between construction and renovation from the houses table, where the derived column for down payment is more or equal to 1, and the years since construction less the years since renovation is not null. And that is going to give us our desired result. We have successfully created 2 derived columns, and from those 2 derived columns, we have also used them to do the where clause to filter out. And again, you could have done this as a CTE or a subquery. If you want to challenge yourself, I actually would say try querying, getting this exact same result, but with a subquery or a CTE. You will notice that there is some different syntax. However, in principle, it is pretty much the same. And the last operation that we will do in this video is just get rid of the houses table. Just for these purposes, we're going to execute this, and we're going to drop this table. And with that, that is everything I have for today. I hope you found this video useful. And if you did, please leave a like, leave a comment. I appreciate any kind of feedback, any kind of support. Thank you. Have a good day.